The thermoelectric effect. We decided to do our project on the thermoelectric effect and how it can be used to harness wasted heat energy to improve the efficiency of a system.
Why we chose the thermoelectric effect. We find it interesting because it uses wasted heat energy and converts it into useful electrical energy. At the moment, the amount of energy created is minuscule. However, if the efficiency is improved, then thermoelectricity could be part of the solution to the global energy crisis.
As electricity is mainly made from a non-renewable source that will eventually run out, pressure is on scientists more than ever to come up with a solution. What is the thermoelectric effect? Thermoelectricity is the conversion between heat and electricity. All materials exhibit the thermoelectric effect, but the name thermoelectric materials is used to describe materials that are good at converting heat to electricity.
It is based on three main effects: the Seebeck effect, the Peltier effect, and the Thomson effect.
The Seebeck effect states that when there is a temperature difference across a conductor, a voltage is produced, which can drive a current in a closed loop. If the temperature difference is large enough, some Seebeck effect devices are able to produce a few millivolts. However, to increase the number of volts, you can connect multiple devices in series, or to increase the current, connect in parallel.
The Peltier effect is the opposite to the Seebeck effect. When a voltage is applied across a thermocouple, a temperature differential between the two junctions is formed by removing heat from one side of the metal and transferring heat to the other side of the metal. This is used in many small devices as a cooling method to make sure that the device doesn't overheat.
The Thomson effect is the third main principle which makes up the thermoelectric effect. It explains why a metal heats up or cools down. Thomson stated that a metal with a temperature gradient that has a current passed through it must exchange heat with the surroundings in order to keep the temperature gradient. Therefore, the metal must either absorb or emit heat energy.
If the metal emits heat energy when a current passes from the hot end to the cold end, then it is a positive Thomson effect. This occurs in metals such as zinc and copper. Metals such as nickel and cobalt give a negative Thomson effect as they absorb heat energy. The heat exchange with the surroundings is proportional to the electric current and the temperature gradient.
Proving the thermoelectric effect. Experiment 1. We set up a temperature gradient using ice and boiling water to prove that a current is produced. The two wires we used were copper and nichrome. As you can see, the current produced is 0.4 milliamps, which definitely isn't enough to power anything.
So we decided to increase the temperature gradient by using candles. The only problem with this is that we couldn't measure the temperature difference. However, this only produced 0.6 milliamps, still not enough. Finally, we resorted to the Bunsen burner, where we produced 1.6 milliamps.
Experiment 2. Next, we began to think about the relationship between the temperature difference and the amount of current produced. We conducted an experiment in order to find this out. Because the number of milliamps produced was so small, we realised we couldn't use a milliammeter. Instead, we use a galvanometer, which is a very sensitive device for measuring small amounts of current.
We boiled the water and waited for the temperature to drop and recorded the current every 5 degrees. We repeated this experiment 3 times in order to make our results reliable. Our results show that the change in temperature is directly proportional to the current produced.
Experiment 3. After doing our other experiments and seeing just how little current is produced, we wanted to try and increase the current produced without changing the temperature difference. We decided to do this by putting the thermocouples in series to make a thermopile. We used a candle to create a temperature difference. We started by just having one thermocouple, then we added one each time to a point where we had 6.
As you can see, having more in series increases the current. This is because for the voltage of the circuit you add together the voltage of all the batteries, in this case the thermocouples, and due to the voltage increasing, the current increases, as current is directly proportional to voltage.
Current applications. In cars, engines produce a lot of wasted heat energy. This wasted heat energy is usually just given off into the environment. However, some car companies, for example BMW, use an automotive thermoelectric generator to convert the wasted energy from the internal combustion engine to electricity using the Seebeck effect, which we talked about earlier. This is used to reduce fuel consumption. Even though it doesn't produce that much extra electrical energy, it has the potential to.
At the moment, around 30% of fuel is wasted in exhaust fumes. If this could be converted into electrical energy, then a car would be so much more efficient. IKEA are currently funding a study on how the thermoelectric effect can be used in furniture. Their idea is heat harvest, which is where the wasted heat energy from everyday objects you already use, such as your laptop or a cup of coffee, to charge a portable device, like a phone.
They use sensor pads and a small thermoelectric generator embedded in the furniture to transfer the heat energy to electric energy. This electrical energy is then used to wirelessly charge your phone. Our future ideas. If the thermoelectric effect can be used in a car or in furniture, then why can't it be used in other applications such as an aeroplane? An aeroplane engine produces a temperature of around 900 degrees C, and whilst in flight, the external temperature of an aircraft is around minus 120 degrees C when at an altitude of 35,000 feet, which is typical cruising height.
The electrical appliances that would be run from the generated energy couldn't be essential due to safety regulations. However, things such as TV screens or radios could be powered using what would be wasted heat energy. This could make flying a little more green.
Thank you for watching.